Alright, geometry, here comes video 2 covering 2-3 on these parallel lines and the triangle angle sums. Alright, so let's just do some problems now. So what are the values of x and y? So if I look at this picture here, let's focus on where x is, right? X is in this bottom right angle, angle S. And actually there's three triangles. There's the two small ones and then the big triangle. We're going to focus on this triangle on the right. I'll use blue. Triangle RST, right? So in triangle RST, you're given two of the three angles. So in triangle RST, if you add your unknown angle x to the known angles of 78 and 32, you should get 180 using the triangle angle sum, which we just proved at the end of the last video. Combine your like terms. So this is x plus, that's 110 equals 180. We're going to then subtract 110 from both sides, and you get x equals 70. And there's your value of x. And now to find y here, I'm going to draw segment QS and then just segment RT or TR and show you that these two angles form a linear pair. And linear pairs are supplementary. So we add them together and set them equal to 180. Okay, we'll subtract 78 on both sides, and y equals, and that is an angle of 102. Okay, so the second big theorem of this set of notes is the triangle exterior angle theorem. So it says the measure of each exterior angle in a triangle equals the sum of the measures of its two remote interior angles. So again, we talked about the triangle interior angle theorem. Now it's the triangle exterior angle theorem. So if we have an exterior angle, it's going to be equal to the sum of its two remote interior angles. So in this picture, angle 1 is the exterior angle. It is exterior because it is made up of a side of the triangle and an extension of the side of a triangle, right? So now it's going to be equal to the sum of angles 3 and 2 in this picture. Notice that this angle right here, I'll put a star, is not used. This would be the angle adjacent to angle 1. Do not use that angle. So I'm going to put a big blue X to it. Do not use that angle, right? Use the two angles not adjacent to the exterior angle. And this is your formula. The measure of angle 1 equals the measure of angle 2 plus measure of angle 3. So in this picture here, 120 is my exterior angle. So 120 should equal the sum of, and then my two remote interior angles are the 90 and the 30. And what is 90 plus 30? That is 120. So this works. All right. Now the one thing I did want to talk about is, what if we focus on this angle here? I'm going to call it x, right? Well, what are the two relationships here with x and the left and right side of this triangle exterior angle theorem? Well, first of all, the 120 and x are a linear pair. So x plus 120 is 180, linear pair. Secondly, x is the third angle in this triangle ABC, so that x plus 90 plus 30 equal 180. Again, this is the triangle angle sum. But if you look at 90 and 30, 90 plus 30 is 120. So again, x plus 120 equals 180. So the idea here is that this is why the exterior angle and the two remote interior angles are identical. This idea. So hopefully that kind of makes sense to you. You know, looking at those the two theorems, the triangle interior angle sum theorem and the triangle exterior angle theorem. All right, good. Let's look at two more problems here. All right, so the first question here is, what is the missing angle measure in the figure? So we're looking for angle 1. Angle 1 is an exterior angle. 45 and 75 are the two remote interior angles. So the measure of angle 1 should equal the sum of the two remote interior angles. And if you add 45 and 75, you get 120, and that would be degrees. And that is the measure of angle 1. In the second figure, again, what is the missing angle measure? 2 is our missing angle measure, but it's one of the remote interior angles. 109 is your exterior angle. So it is going to be 109 that is equal to the sum of angle 2 and 51 degrees. And now to get angle 2 by itself, you have to subtract 51 on both sides. And when you do that, you get 58 equals the measure of angle 2. So the measure of angle 2 equals 58 degrees in this case. All right, very good. Last but not least, let's take a look at even a more complicated picture. So it says Cheyenne built this display for her ornament collection. Each shelf is parallel to the base. So again, this is a big idea. Each shelf is parallel to the base. Right? And it says she recalls only the angle measures from the diagram. Now she wants to build another just like it. What are the measures of angle 1, 2, and 3? So we've taken this section right here. Okay, and I'm just going to draw, right, the inside piece, and we moved it over here. So that's what we've done. All right, so in this picture here, we know that this piece right there is parallel to the base. Okay, so we're good there. And now we need to find angles 1, 2, and angle 3. So how are we going to do this? Well, if we take a look at this picture here, we can use the parallel lines to help us find angle 1, right? So if I sketch this parallel line, I sketch this parallel line, and this transversal, the 75-degree angle here is corresponding with angle 1 in the 55-degree angle down there. Okay? So we can use corresponding angles, parallel lines, corresponding angles, to set up the following equation. The measure of angle 1 plus the 55 degrees will equal 75 degrees. Okay, again, corresponding angles, they're congruent. And if we subtract the 55 on both sides, we get that the measure of angle 1 is 20 degrees. Okay, so there's our first angle measure right here. Angle 1 is 20 degrees. All right, now, what about angle 2? Well, to find angle 2, we're also going to use the parallel lines. So I'll trace them in purple this time. But now we're going to use, this as our transversal. And I think I've said this, and if not, you'll hear me say this when we do congruent triangles. See the Z, right? This is a little backwards Z. This means you have congruent alternate interior angles. I use 2 arcs for angle 2 and the 55-degree angle. See how they're kind of made in the corners of this Z? So we can say that because of the alternate interior angles theorem, the measure of angle 2 is 55 degrees. Right, no work necessary. And there's another 55-degree angle. And now we want to find the measure of angle 3. And lucky for us, angle 3 is in this triangle right over here. Right? Now, in order to use this triangle, we can't use the one I just tried to outline because we don't know angle 4. But if we continue this all the way to this 45-degree angle, and we take a look at this bigger triangle, we have this corner angle, we have that corner angle, and then this corner angle right here is made up of 55, angle 1, which is 20, and angle 3. So it takes a little vision, but we can use the triangle angle sum theorem to set up this equation. And I'll start with the measure of angle 3 plus the 20 degrees plus the 55 degrees. So that's all this angle here, plus, then I'll go to this 45-degree angle here, plus the other 45-degree angle up here, and that's going to equal 180 degrees. So again, we're combining multiple angles, but again, it's just the 3 corner angles of that green triangle. So if we combine all of these like terms, this is 20 and 55, which is 75, 45 and 45 is 90, 75 and 90 is 165. That equals 180, and we subtract 165 from both sides, and we get that the measure of angle 3 is 15 degrees. And there we go. Great, so hopefully you feel comfortable with the triangle angle sum theorem and the triangle extended angle theorem so that you can use them to solve more problems. All right, thanks for watching.